Good morning, everybody.
Morning.
Good morning, everybody. Okay, you guys don't need to turn on the camera or the audio on right now, so that should be fine. Okay, but down the road, probably we will, especially if we're going to meet on a one-to-one. If you have questions or something like that, you need specific help with the project or something, you guys need to let me know immediately. Okay. I need to get a feedback all the time while we're interacting online on the live session to get a feel that everything is working or not, especially in terms of sound and video and in terms of files that are being shared, because at some point I will be sharing my screen and I will be talking, and if it doesn't make sense to you, please raise the issue immediately. While I will be doing that, it may be that I will not be looking at the screen, so you might need to speak out. You might need to say, hey, I can't see the screen or something like this, okay? So let me quickly tell you what I have in mind. Meanwhile, you have the chat session going, so you can ask specific questions. You can ask anytime. It doesn't have to be at the end or in the beginning. That's one thing. And then also you can follow up later on. You can always send me a message saying, hey, I was not clear on that issue or this one. And it's a good idea, and we're going to talk about that one, to go through the Canvas when you do that. Okay, don't send emails or text messages or something like that. Canvas will keep a record of all of these things, and in case you want to come back to it or somebody else wants to come back to it, it's a lot easier for everybody to work off of that platform. So that's in a nutshell. Let me first of all share with you the points that I have in mind. And where is the screen in here? Share. Okay. So these are the items that I think I'm going to talk about today. Again, if you have anything else, I'll be more than happy to cover on those things too. So the first one is, I already mentioned the issue of the software, namely the fact that we have to have Stellarium, which is important for some of the projects that we're going to have down the road. And I gave you the link also for it. And also you will need an Adobe Reader, and you will need it soon, the Adobe Reader. You will need it probably this weekend, so don't delay that. And there are some other things also that probably mentioned in the software list in there, including a Word editor, including a cute PDF to convert stuff, things like that. Does anybody have a specific question, especially about Stellarium? Okay, let me stop sharing. No? Did everybody, or at least most of the people, had a chance to go and look it up online? Okay, good. At least few people did. Hopefully, the others also will follow suit, because you will need that software. It's not really, it's free. Everything I'm giving you in here is either free or you can access it online. So there is no issue in terms of getting these things. So you will need that, okay? You will need that for another project in here that, like I said, we will need down the road. And also, because we don't have access really to the planetarium where we do stuff on the planetarium, so we're going to do something which is close to it, which is Stellarium. And Stellarium actually has more stuff in it than the planetarium. It has more information for us, and it gives you a live view of your own, basically, location where you are. So there are benefits for the Stellarium, especially if you don't have a telescope also. That's actually a very powerful tool to have. So that's one thing. The other thing also is the course organization. I know I already gave you a brief overview of how this course is modeled. Basically, the biggest thing, and let me do that quickly so that we're looking at the same thing in here. Let me go into the screen and prepare it before I show something else. Okay, so let me go stop sharing that screen. And let me share with you how the course is organized. Again, when you land on the course, you will see this page, which is basically what probably most of you have done already. You will see the syllabus in here. The syllabus is not written in stone, so we probably have to download down the road, change it, because of the fact that it was really modeled off of a face-to-face instruction. So I'm changing it to completely online, because this course is going to be 100% online. Nothing is going to be in the contact. So this is basically how the course is done. Today, the project for the Mars, retrograde motion of Mars is going to be posted. Actually, probably it has been already. So I need you to start working on that project. and I will tell you exactly how this is going to be graded. As a matter of fact, you will see the rubric in there, how it's graded. So please follow the rubric and make sure you meet all of the expectations one by one as you are going along with it. If you have any question about it, please do not hesitate to ask. I'll be more than happy to record the session with you one-on-one and post it again for everybody else to benefit from. So that's basically one of the things that we're going to be talking about today too. The other things also that are due starting from next week is actually the lunar observation project. That's actually a little bit easier than retrograde motion. So because all you have to do is go outside basically and look at the moon and take the note of the date and the location where you are, and that's it. And the shape of the moon, and that's it. So that's basically how the second project is. And those are graded projects, so they are very important for your, and you saw the grading policy in here that you hopefully you had a chance to go through. So all of the things that they're part of the how the course is organized and how the things are done. One of the things that you probably have done already is this modules. That is where you should always be. That is really where the point that you need to be on a regular basis. As I explained in the intro, basically video, these modules are sequential. You have to do one before the other. One word of caution that I did not warn about last time, and it's very, very important that you really have to pay attention to. Some of these modules actually, they are actually multi-tabbed models. Basically, like for example, it looks like I don't have a lot of content in this one, but if I click on the next tab, I will see more information in here. These are just points that I want you to remember in here. So if I go to the laws of nature, I have some examples in here. If the numbers in astronomy, it takes more examples and more links for the scientific notations and everything. I urge you strongly to go through all of the tabs before you do anything. As a matter of fact, there is an example in here. There are 2 examples in here, so I want you to work out the examples. If you have questions, first of all, these are not, they're not my invention. They're actually off of the book. So go back to the book, ask me, ask something, and let's make sure that this thing is fully done. So in other words, what looks like it's just one item in here, 1.2, an overview, is actually several topics. Each and every one of them has its own basically stuff in it. So it's very important that you go through each and every one of these tabs. So that's hopefully that you already have discovered that. If not, hopefully you guys are already aware of this, okay? So you're going through this. So this is just in a nutshell, basically. Let me go back into my notes, what I wanted to talk about. So this is in a nutshell the organization of this course in here.
Excuse me, I have a question.
Yes.
So on mine, when you went to your module, it showed that it had checks on the side of each one you completed.
Uh-huh.
After I went through, because I had finished 1.2, 1.3, I read through them, and then I did the assignment, but it only shows a check at the top and doesn't show a check on the other assignments that I read through.
I'm not sure exactly what you're saying, Naomi, but I will, okay, let me go back to the models. So it shows a check on the community rules, the 1.2. Did you do this one? Yeah,
okay. Yeah, I did that. Mine only shows a check at the top on the week 1, and it shows a check at 1.1. But I read through 1.2 and the flat Earth and 1.3 as well.
Yeah, let me see if there is something. Does anybody else experience the same problem, or just
yes? Yes, my question was, she's right, spot on. Do we need the check marks for 1.1, 1.2? As we go through the modules, do we need the check marks, or to make sure you know that we did it? Because mine didn't do it either. I read 1.1, 1.2, and I'm working on 1.3.
I think it's probably my fault, because I need to make sure that the completion has to go through, because I think I probably did not do all of them. So okay. I need to go and set it up so that if you did one, it has to be required for, basically I have to really build the sequential stuff in here myself. So I think there is a problem that I need to fix myself, okay? If that's okay. The case, then I'll have to work on it to make sure that you do that. So, okay, some things are going in the chat, okay? Okay, So again, Joshua is saying that he has to go to work. You guys are not required to attend, like I said, but questions like this will never pop up if nobody is really, if people don't show up. So it's fine. I mean, we're going to post this one, and hopefully people can still ask questions later on if there's other issues. So I'm going to fix this one, hopefully. Yes?
I also had one more question. I think it was at the bottom of 1.3 that there was a Stellarium activity. When I went onto the Stellarium site, it didn't, like, it was just the website. I don't think there was any particular activity on the site. I'm not sure how that works.
Okay. For the Stellarium, you really have to download the software. Okay?
Mm-hmm.
You have to download it on your computer, and the Stellarium activity is still not posted. So it's still not due yet. So I'm going to post it next week for you guys to work on. Okay?
Okay.
But just a note in here that this is coming down the road that you have to complete, because the idea, and I don't want to get into the details right now, but the idea is basically you're supposed to go and look at objects in the sky using the Stellarium, and coming back into this idea of how the Earth basically moves around the sun. And you will note that different times of the year, you're going to be seeing different positions, for example, of that object, number one. Number two, also, you're going to be monitoring specifically the sun in that activity, and you're going to look at it in 4 dates: on June 21st, 2020, on September 21st, 2020, and then on, December 21st, 2020, and also on March 21st, 2021. So you're going to be looking using the Stellarium basically, and looking at the different positions of the sun and taking note of its actual coordinates, not just that it appeared here and there. You're going to take note of it, and you're going to draw, and you come back in here, then it makes sense to you. That is really the connection, and it's going to be specifically stated in the project itself that, hey, you have to go back into way back to 1.3, and that will make sense to you. Do you understand?
Okay.
That should make sense to you down the road. Right now, I mean, the website is just a website. It doesn't do anything. So it's basically we have to download the software from the website. And then, did you download it? Did anybody else download it?
I haven't downloaded it yet.
Okay, let me get the Stellarium going on my computer so to give you a feel.
The Stellarium is actually really awesome. I downloaded it. It's in 2 parts. Just follow the link when you use the syllabus. I used it. It's good.
Yeah.
It has like the full, like you said, the telescope thing. It was awesome. You gotta go when you get off, when we're finished. Just go to the syllabus and then download the 2 versions. It has a 64-bit and a 32, I believe. It was really good. It'll help like everything.
Okay. Honestly, you don't need both versions depending on your computer. If your computer is using a 64-bit, download the 64-bit. If your computer is using the 32, use the 32. Here is my version of it. So I'm going to share the Stellarium right now. Does everybody look at it? That you're looking at like what looks like it's a map or something like that, like the Earth or the ground. Okay, good. So basically, this is right now. So what you do in here, you're going to come to the time and date. Okay, where is it? Okay, it's in here. Yeah. And change the time. For example, right now it's, what is it? We are on June 24th, 2020. This is using military time. So I'm going to be using 8 o'clock in the afternoon, which is 20 hours. So this is how the sky would look when I'm looking between the south and southeast. So for example, around 10 p.m., which is 22, this is how the night would look like. So I'm going to be monitoring objects. This is where Jupiter is located. And if you look at then here, on the side, you will see specific items, including the right ascension, which is needed for our project, and the azimuth or the altitude, which is needed for our project. So these are the things that we will be looking. Jupiter is kind of a planet. It's a planet, so it moves fast in the sky. So that's why you will see this thing's moving super fast. But if I pick up a star in here, it should not. Oh, I'm sorry. It moves because the Earth is spinning too. Okay, that's another thing. So if I pick up a star, that also is going to do the same thing. So Altair, for example, this is a star. Also, it's moving. That's because the Earth is spinning. Okay? So right now, it's in that location. If I wait a little later at night, Altair, for example, will move. So I'm going to move it to 11 o'clock at night. Oh, this is 22. That's 11 o'clock. Let's make it 23. No, that's 22. It's 10 p.m. What am I talking about? So, yeah, so it moved completely, okay? So anyway, I didn't mean to do this as an introduction to the software. I just want you to get really a feel for it, because we're going to be doing stuff with it too. So that we will. Okay, let me go back into the screen where we were way before we started this, which was here. So again, I hope that you guys are going through these things and reading through them and doing the activities whenever is possible. The biggest deal in terms of stuff, let me go into my notes to make sure I cover all the things, is the project that is actually today, okay? That was given to you, the retrograde motion. So I want you to really pay attention to this project because it's work intensive. It's made up of 21 items that you have to complete. And these 21 items, they are actually quite a bit. So let me go back into the models. Probably a good idea for me to mimic the fact that if I am a student, because right now I am a instructor. So let me change it to a student view and see how it looks like from your vantage point. Come on. Are you looking at the browser now? Yes? Okay, good. So right now I'm going to go to the models again. And this is the, oh, I did not complete it myself, so I probably have to go through it. Oh man, they're terrible. So, I know what you're saying now. I should probably use this. Okay. Obviously, this is not what I want you to do. I want you to go through all of the tabs. So I should have finished this task in here. And hopefully you guys have shared your information in there and you're going to respond to other people also. Okay, so I finished this. Because every time I come in as a student, so I have to do these things and you have to complete the tasks as a student. Otherwise, it will not really take me to what I need to do. Okay, in here, this is the retrograde motion. Okay, this is the project. Okay, this is the instruction for the project. What is given to you here are the dates between 2005 and 2006 for the position of the planet Mars in those 2 years. Okay, it starts from July 10th, 2005 and ends on March 20th, 2006. The way you read this table is coming down in here, July, August, September, October, November, then December of 2005, then 2006, that's in January, all the way to March 20th of 2006. What you're given are two pieces of information. The right ascension, which is measured in hours, and the declination, which is measured in degrees and seconds, or arc seconds. This, if you read through the chapter, you will see an explanation of how basically the celestial sphere is, and how basically the horizon, and also the zenith, which is on top of your head, basically how the dome is forming on your head, and how we're dividing this position of objects in the sky with angles. Of course, we use the angle on one of them using the 24-hour clock, namely the right ascension, but the other one is a declination, which is actually in degrees all the way to the zenith. So these are the positions in the sky. So think of Mars as an object that it was here, that it appeared in here on a specific time tonight. Tomorrow it's going to be appearing in here. The next night it's going to be appearing here, and so on and so forth. These are its position on that dome. So now you have the angles. And the what happened to the graphs, to the pictures? Okay, so we're gonna get the pictures anyway. So let me go into the PDF file. In the PDF file, first of all, by the way, this is the rubric. This is how you're going to be graded. The objective is out of 5 points, and this is what you need to have in order to earn the 5 points. If you don't, this is the points that you will get. If not, if you don't do it, this is how much you get. So I would recommend that you go through, while going through the project itself, also to look at this rubric to make sure that you're meeting all of the requirements so that you don't miss any points. If you have difficulty doing any part of it, please let me know, okay? And again, we're going to go and record it. So let me go back, and I don't know why the image did not show. So let me open the PDF file right now, because this is just a PDF file, and I'm going to stop sharing that screen because the PDF file popped up. So I'm going to share with you the PDF file right now. So this is the PDF file that you have on your screen. This is following the instructions, and it's giving you a room for you to fill. Again, you really need an Acrobat software to do this. Do not, because if you click on it right now, probably I would say 95% of the chances it's going to be opened by your browser, either Internet Explorer, Firefox, whatever. If you're on a Mac, you're probably using a Safari. So any of this software might attempt to use it. Do not rely on them. Please go and open the file, download it on your computer, and open it with an Adobe Reader. Then come in here and fill your name, of course. When you see a red thing in here, that is a requirement. So if you try to save this file without this filling anything in here, including a space will be considered a fillable file item. So please answer the question, go back into the rubric, see what is required from you, and make sure you basically item 1, 2, 3 and answer them, and you have to fulfill the objective. You read again, this is divided into 3 sections. 1, retrograde motion of Mars. 2, actually the mapping using the heliocentric model and also the geocentric model of the position of Mars. And 3, which is actually the other celestial object, because this project is not just specifically for Mars, it's using Mars as a model because it's a retrograde motion. So basically, if you didn't read the chapter, is in the old days, people had a problem understanding how is come that all of the planets seem to be moving in one direction, except Mars in some weeks it's moving backward and then moves forward. So that motion backward and then moving forward was called the retrograde motion. It was later on observed that also Venus does it too. And that was a problem which prompted Ptolemy to come up with a model for its motion. And he said that basically, look, in order for me to explain to you what's going on is, look, Mars is going through a circular path around some point where it's going around the Earth, because in the geocentric model, the Earth is the center of everything. All of these objects that we see in the sky, they are moving around the Earth. And the Earth is the center, basically, of the solar system. So while it's going backward in this motion, it appears to be moving in the backward location. So this is the geocentric model. So what you do in this case, I'm going to take a tool in here from Adobe. And I'm going to take content, maybe? No, or comments? Comments, yes, comments, okay? I'm going to take the line in here to draw just a line. So what I'm going to do, I'm going to connect this point with point 1. And if I am sitting in here on Earth, this is where Mars looks to me, okay? Looking at it, this is how Mars appears to me in the sky. So I'm here on Earth looking at Mars today. This is how it looks like. On another date, for example, this is how Mars looks like. For example, it's going to extend this line, line 2. So I'm going to come in here and draw the position of Mars. So again, it has moved from this location to this location in the sky as far as I'm concerned. In a later date, I'm going to look at Mars, for example, and connect it. This is, so we're going to go sequentially, 1, 2, and 3, and so on and so forth, okay? So Mars is still moving forward. You guys see that? It was here, now it's in here in the sky, and now it appears to be here in the sky. So this screen in here, the projection is actually the sky. So I'm going to look at it on another date, because now it appears, because this sphere is rotating while it's moving forward, that Mars is actually here. So it's somehow slowing down in the sky, okay? And if I continue with this pattern in here, so Mars probably now, oops, this line is not correct, so it's probably here. I trust that you guys do a better job than me in here when you're drawing it, but I hope that you also understand how this is interpreting the motion of Mars in the sky. So anyway, let me draw another line in here for, let's say, for example, 8, okay? So I'm going to draw 8, and it's clearly 8 comes backward again. So if I connect all the dots and label this one 1, this is 2, this is 3, this is 4, this is 8, there is a 5 somewhere in between, there is a 6 in between, there is a 7 in between, and there is a 9 that is probably going to be moving forward, and so on and so forth. And here, and then the planet appears to be moving forward again. You guys see this connection in here? So this is from the vantage point of the geocentric model, where the Earth is the center of the universe, or the center of the solar system at least. Now, in the heliocentric model, basically what is going on is the sun is the center of the solar system, and the Earth is closer to the sun and moves slower than moves faster than Mars. So if again I do the same thing and try to project my viewpoint on Earth, I connect 1 to 1, and this is where the Earth looks like, and here it's located. I connect 2 to 2, and this is how the Earth look like from my vantage point in here. Okay, so again, it's moving forward. So 2 and 2, they should give me more or less the same behavior. So if I go, for example, in 8, for example, to give me the, let's do 7 first, okay? 7 is also moving backward, 6 is moving backward, 5 is the same point in here. So 5 is probably where it starts to move backward. So all of this time it's moving this way, and 6 is moving this way. So 6 appears to have moved backward completely. You guys see the idea in here too? So this is in the heliocentric model that still also explains the retrograde motion of Mars, but one of these two is real, and the other one is a mathematical construct that is not real. So this model and the other model, both of them give you an interpretation of the same thing, which is the retrograde motion of Mars, but one of them is corroborated with other evidence to be more realistic than the other. So that's part of your job to understand why the heliocentric model is really more acceptable than the first one, which is at the heart of what the scientific method is. You come up with a model, you explain a phenomenon, and then if that explanation starts to falter for other experiments, then you say, hey, maybe my model was wrong, so you correct the model. And this is exactly how we evolved in here. Astronomy is really a very powerful teaching thing about the scientific method. Please make sure you fill out this ones in here. If you cannot do it on the screen, you have to do it by hand. Okay? If for example, you filled out all of the parts of this project and you could not draw this graph or this graph, or as a matter of fact, there is another graph in here that for some reason, yes, because you're supposed to take all of the dots, remember, from the previous data that I gave you, the 2005 and 2006 data, and you're supposed to find 1 hour and 34 minutes. For example, this is 1 hour. This is 60 minutes between an hour and between 1 and 2. So this is 10, 12, 30, 34 minutes should be somewhere in here. And then the angle in degrees is going to be somewhere in here. Okay? 15, for example. So I'm going to put a dot in here on, what is it? Sometime in July 7th or whatever that is, July 10th of 2005. And then I move to the next dot, the next dot, the next dot. And then I connect them and I will see that the planet Mars actually is moving backward also and then forward. And you're going to ask specific questions. When did the retrograde motion start? And when it resumed, the planet resumed its regular motion. So you need to answer this based on the graph. So all of this basically is just to give me an idea of how to do things in here. The last part in here is the calculation of this project in here. Basically what you get to do is you have how long does it take specific planet, you're given 6 planets other than the Earth in here to go around the sun. Mercury does almost 3 months, 2.89 months around the sun. Basically for every one of our years, Mercury goes 4 times around the sun. Okay, if you can think about it that way. Venus is a little slower, but it's actually in 7 and 0.38 months, it goes once around the sun. So every 7 months and a little over half, the Venus has already completed 1 year on its path around the sun. So, and you can imagine, basically, it's moving faster because it takes us a whole year, 12 months for us to complete the same cycle. Mars is slower because it's further. Again, it takes almost 2 years to complete the same time to go around the sun. That's why the Earth appears to be catching up with with Mars and then moving back. That's why there is a retrograde motion. It's like the train, for example. You're driving on the freeway and you're passing a car in here, and the other car from your vantage point appears to be moving backward. So that is really what's going on in here for the retrograde motion of Mars. So because we're catching up with it, it appears to be moving backward. And it's the opposite for Venus and Mercury because they are actually the ones who are overtaking us. So they appear to be at some point moving backward and then forward faster than what they appear because of that relative motion. Ceres, which is one of the dwarf planets that exists between Mars and Jupiter on the so-called asteroid belt, it's a big, basically round object, also takes about 55 months, which is almost, what, a long time, basically. Not exactly 5 years. Much 55 months? Yeah, it's less than 5 years. Anyway, it goes very, very slow because it's further away. Jupiter takes almost 10 years, 142 months. So it's very, very long time for it to go around Jupiter, no, I'm sorry, 5 years. What is my math in here? 12 months is 1 year times 10. Yeah, it's actually more than that. Anyway, Saturn is 356 months. So you have the math in here, and there is a formula in here. Let me stop this in here quickly to show you the formula that you need to be using because it's important. Let me go back into this screen. Let me go back to the instructions. Why is this image not showing? There are some images in here. These are the images from the same images that are in the instructions in here. So I guess, is this the same problem for you guys when you went to it? The images are not showing?
Yes.
Okay. So it's the same images that we were looking at, the same graphs, the same stuff that you were looking at from the instructions. So if that's still not clear, I'm going to make the whole instructions in PDF again and upload them there in addition to the HTML. For some reason, it's not showing. Okay, so it's the same images. Anyway, this is the formula I want you to look at. This is the one. Okay, so what you do in this case, you take this number, 2.89, and you multiply it by the Earth, which is 12. Okay, so what I do in this case is, okay, let me use this pen in here. 2.89 times 12, okay? And divide by the difference, 2.89 minus 12. And take the absolute value. What the absolute value means is ignore the sign. So if it comes out negative, just write it without the sign. So that's basically what that absolute value is. Oh, I'm sorry. I'm not sharing this screen, am I? Let me share this screen in here to show you how the math works. So basically what you do in this case is 2.89. I'm doing Mercury, okay? So I'm going to take 2.89, that's for Mercury. And then I'm going to multiply it by 12. So my calculator says 2.89 times 12 is 34.68. So that is the numerator. So the numerator is, okay, why is this? The numerator is, what did I say, 34 or 36? 2.89 times 12. 34.68, okay? So I'm going to 34.68. That is the numerator divided by, again, 12 minus 2.89 minus 12. That's going to be a negative number, but like I said, I don't care about the negative number, okay? So when you do this, you ignore the negative number. It's negative 9.11, okay? Technically, it's negative 9.11, but because of the absolute value, so whatever answer I'm going to get, I'm going to ignore the sign for it. So 34.68 divided by 9.11. 34.68 divided by 9.11. So that's going to give me 3.806, okay? Or 3.81 or 3.8, okay, roughly. 3.8. So that is S. Again, it's negative, but I don't care about the negative number in here. All I care about is the positive number. So I'm going to stop sharing the screen in here, and I'm going to go back and share the PDF file in here with you guys. So that number needs to go here, okay? So let me go back into the PDF, actually. stop sharing the screen. I can go to the PDF because the PDF is the one that we're going to be using. So I'm going to write in here 3.80 or 3.8. Okay, that's fine. Okay. Now I need to do the following. I need to count. I'm sorry, in months. Yeah, 3.8 months. Okay, 3 and 80% of a month. How many days? 80% of the month. Again, it's easy. We're going to just okay. So 3 months after the February, I have February. Then comes March, April, May. So it's May, and then I have an 8/10 of a month. An 8/10 of a month again. I'm going to go back into my stop sharing this screen in here to find the exact date, okay, when the next occurrence is supposed to happen. So I have 3 months, which put me in February, March, April, May. So it's going to put me in May 26 because 30 days, I mean, that's basically if I add 3 months to it. And let me go back into the screen in here. Okay. An 8/10 of a month, 8/10 of a month, 8/10 of a month is just 24 days. I mean, if you want to, 8 times 30 divided by 10 is 24 days. Okay? So I'm going to count 24 days from what? So 24 days from 3 months after February 22nd. So this is going to be May 22nd to 26th. I'm sorry. After February 26th, I have to count 3 months, which is put me on May 26th, and then add to it 24 days. So that's basically put me somewhere in June in here. Okay. So it's going to be 6. So May is 31 days. So it's going to be so June 19th, if I do the math correctly. So that's basically the answer to the first one. Okay. Now I have answered the first one. I do the same thing, but instead of 2.89, I use 7.38, and then I start calculating from this date to find the next date. And the same thing in here and here and all of them. If you have difficulty with the calculation, please do ask me, and we should be able to finish this one. It's due next week, so I'm hoping that you guys can finish this one and have an understanding, a better understanding of how the retrograde motion works. Okay? Okay. Any questions? No? Okay, let me go into my notes in here to make sure that I have covered all of the things that I'm supposed to have covered today, at least the ones that I had in mind. Yeah, chapters 1 and 2 quiz are going to be next week. The first, they're going to be posted, they're going to be posted this weekend, the quiz, but it's due next week. So it's going to be part of next week's assignments. But they are covering actually the quizzes for this chapter. Okay? Okay, if you guys don't have any questions, other than the fact that I have to work out on some of the couple of issues that we have in here, namely these check marks and also the pictures. I don't know why they are not showing, but the pictures there is an easy fix because I'm going to post actually the PDF file and be done with it. So at least you'll have the actual instructions, the full instructions with the pictures and everything showing. No? No questions? I did not really want it to go too long. What time did we start? Oh no, we still have time. I was hoping to go more than that. Okay. Any questions? Do you need clarification on something, or is everything clear? Or should we go through another thing in here, at least to have a better understanding of things?
Can we go through one more thing?
For that table or for something else?
Anything that's we should expect through the course, just so I can get it done.
Okay. The projects basically are important, so I really hope that you guys start on these things as soon as possible. Do not leave them toward the end and then start thinking about them. In terms of the the second project, like I said, it's a little bit easy, but if you miss the window, you're going to have difficulty doing it. The second project is actually going outside on a clear night and looking at the moon, okay, trying to find it several times of the okay, that's a good question from Casey. I'm going to go through it. Anyway, the question, basically several times of the night. So if the moon is not visible for some reason or the other, let's say for example the night is cloudy or something like that, it's the next night. Immediately you're going to look at it. And let's say for example, for some reason there is too much cloud or there is something that says, okay, the moon, you cannot see it tonight. So you go the third night. Now if on the third night, and you go sporadically, you go for example at, what is it, the sunset right now goes around 8:10, 8:15 in our area. So maybe around 8:30 p.m. and look at night at the moon, okay? Now, if you see the moon during the daytime, hey, that's easier. Okay, hey, the moon is here at 10 a.m. in the morning, it's in here, okay? On that date, not any other date, on those dates where they were assigned for you. And then you're gonna locate the location. For example, right now, I'm looking at, what is this? East. So this is east as far as I'm concerned. This is where the sun comes from. And then I continue like this one on the east side, somewhere in, this is my zenith, okay? So I say somewhere, for example, immediately on the east. But if I see it, for example, southeast, I'm gonna say I saw it southeast roughly about halfway, okay? You don't have to give me degrees or anything like that. And, or if you saw it southwest, I'm sorry, northeast, for example, I saw it northeast, or it could be west at all, completely on that night. So depending on the night that you're looking at it, the location of the moon might be different. So take a note of the location. You take the shape of the moon, because sometimes it's going to be completely around the middle of the lunar month. It's going to be looking like completely full. Sometimes it's going to be quarter. Sometimes it's going to be very faint, for example, a crescent. So you're going to be deciding, or crescent in the other side. You're going to decide its shape and its location and the time when you saw it, and that's it. Now, if you cannot see it, you say, I couldn't see it. It's not there. Or I couldn't see it because of one reason or the other. In other words, I know that we're supposed to be basically being very careful and so on and so forth, but it's a good idea to go out and practice all the safety things for your health, because it's far more important than anything else. But of course, do your observations, okay? So that's for the lunar observations. Now for the flat assignment, you don't, either a website or a YouTube video or any video, as a matter of fact. Oh, there is a Netflix on the, how are you going to share the Netflix movie? That's a question for you. I mean, when you do something like this, I know the question, let me read the question for you guys so that you have, you're not looking at it. For the question of the flat earth assignment, do we have to have a website, a YouTube video? And there is that I thought, okay, there is a Netflix movie that can work. The problem with the Netflix movie or anything that is basically protected, if you wish, like in Netflix, you have to really have an account with them in order for everybody else to see it. The intent is that you come on the assignment and say, this is the link, or this is the video. I saw it on Vimeo, or I saw it on YouTube. Here is the link for it. You can go and look at it yourself. And then, based on that video, you're going to point 1 to items that the basically author has mentioned, and you're going to basically argue against for those flat earth things. Does this answer your question? So my recommendation for the Netflix is not to do it, because it's not going to work. Hulu and Netflix, they're not going to, unless somebody has specific accounts with them, then it's not going to work. That's one problem. The second problem is, down the road, those videos might not be available. So when somebody else trying to look at your work, or you're looking at it yourself, or somebody else trying to remember that discussion and trying to pick up on it, they probably will not find the link available, because those people, they recycle for those materials all the time. Casey, does this answer? Okay. Okay. I hope that that example shed light, at least for the, because in the past, my experience with that project, and I did it at least in 2 other classes in the past, they had difficulty with that table more than anything else. The graphs, they were a little bit of an issue too, but once you know that you're supposed to connect 1 to 1, 2 to 2, 3 to 3, and so on and so forth, and note the location on the sky, you're going to see the retrograde motion as far as the graphs are concerned, the other two graphs. That's one level of difficulty. The second level of difficulty was that graph for the dates, basically. Try to find them on the map. That's actually a little bit easy because all you're doing is, if you have done any kind of graphing in the past, that should work fine. Basically, you find a point on an x-axis and a y-axis. The y-axis is moving back downward. The y-axis is moving basically in time this way. But it doesn't matter for you as far as you're concerned. In this date, this is where Mars was. On this date, this is where Mars is. On this date, this is where Mars is. And so on and so forth. And then you connect the lines. Okay? You connect the dots, basically. And that's the path of Mars throughout the year. Because the path is given only on specific dates, 10 days apart. So you need to extrapolate between those 2 days, 10 dates, to find the line that connects all of them to get the actual path. So that's another level of difficulty. But the difficulty that I saw, at least with this level of projects, is the difficulty with finding S. Once you find S, which is the absolute value, please do not write any negative number in there for S. Again, it's an absolute, those lines, those bars, they're supposed to be for absolute values. You're not supposed to take the signs into account. If you do write a sign, that's fine. I'm going to ignore it, okay? But the main thing in here is try to do calculation correct. And if you have difficulty with it, please do not hesitate to ask so that we can complete this task to perfection. And you have the rubric in there stating exactly specifically how you're going to be graded. So please pay attention to it and see exactly how you're graded so that you don't miss any points unnecessarily. Okay? Yes? Again, this session is recorded. And if you like, you can come back to it and go through the example that I did with you guys. And if you still have any questions or something like that, please do not hesitate to ask and share these things with your classmates. I'm going to change a little bit the project, the second project a little bit, and actually the assignment for the Stellarium, so that it's going to be a group project where everybody has to have an input on those projects. And do not forget that you're also part of your Flat Earth assignment is that you're supposed to respond to your classmates too, okay? And give them your feedback and opinions on it. Okay, I hope that that was a little bit helpful. And we will have other sessions down the road. Maybe I'm planning on 2 times a week. If it's okay with you guys. And again, it's not mandatory that you come in, but the purpose of which it clarifies some of the things that are due and things like that, and answers some of these issues that I don't know exist, but they do exist, so that we can fix them and make sure that this course is going as smooth as it can get. And I will tell you when these sessions are. Most likely, the way that I'm thinking about them is either Monday and Wednesday, and give Thursday and Tuesday just for basically the assignments to be due and all of these things to be basically worked out, so that all of the things are in this order. Okay? Well, if you guys don't have any questions, and please bring some questions like the great question of Casey in here, and make sure that you download the software and everything else. Okay?
Thank you.
No problem. I expect to hear from you guys. Okay, and I'm waiting in front of my computer and my phone all the time.
All right.
Okay, okay, bye.
Thank you. Have a good day.
Thank you too.